Hi, welcome to another Teach Me to Code screencast. This will be a Ruby Essentials screencast about blocks and yield. So, what is a block? In Ruby, a block is any code in between either curly braces, as you see on the left example here, or between the do and end keywords, as you see on this example on the right. So it's just any arbitrary code in between braces or in between do and end. A block can only be given as a parameter to a function. So if you see here on the left, I try to run this, I get syntax error because it doesn't know what to do with it, or same thing with the do end. So as an example of how you can use it, calling to.times is a method call, and I'm passing it this block. And since the block is a parameter to the method, it works just fine, as well as the do end example. So now that we know what a block is, we can go over some of the common uses in Ruby. The first example that I already gave is just repeating a task multiple times. So on the left we wrote the word hip 2 times, and on the right we wrote the greeting hooray 3 times. Repeating tasks is very simple and a very common usage of blocks in Ruby. Another very common usage is iterating over the items of an array and doing something with each item. And this also introduces a new functionality for blocks. If you look here on the left example, you can see that I used 2 pipe symbols, and in between there I put the variable I. So that is an argument to a block. They work very similar to arguments to a method. You could, if you wanted to have multiple arguments in here, in this case it only takes one argument, but it works just like the arguments to a method. So how this works is for each item of the array, this block will be called and the current item will be passed in and stored in I. So if you run this, you can see that it simply prints out each item of the array. And it works the same for a block in between do end keywords. You can see over here I've got the same piped I, and I'm just again putting it out. And you can see it prints 5, 6, 7, 8. So it's just for each item of the array gets passed into the variable inside the pipes. Some more common uses are map on an array. The map function is a very useful function. What it does is it takes the given block and applies that block to each item in the array. So this array, as you can see an example up here, is just says Ruby block yield, but if we run this map function, each of those words will get passed in as the parameter E, and it'll print out, it'll replace that parameter with this. It'll add on the word rocks. So you can see as we run this, we get Ruby rocks, block rocks. So each item, this block is executed on each item of the array. That can be a very useful function. Something else is file writing. Here's an example of writing to a file. What's so special about this is that you don't have to close the file when you're done with it. Because you give it a block, all the opening and closing is taken care of for you. So how this works is the file library, you just simply call open, the name of the text file that we want to pass in W we want to write, and we pass in a do end block, and we're accepting a parameter F, which represents the file, and we just kind of treat the file like an array, and you just write out to it. You just use the double arrow, you can write to it and hit end, and I'll show you an example. So here's a directory this is running from. You can see, oh whoops, I had something left in there, so we'll delete that. So now it's an empty directory. We'll come in here, we'll run this. It says the file's closed. The file's back in there, and you can see it says blocks are nice. So again, the nice thing about this example is that you didn't have to close the file. You don't have to worry about some finally block where you have to make sure the file's closed and all those things. This is a very common usage for blocks, and later in the screencast I will go over how you can do that in your own code. Now I'm going to show you how to use blocks in your own code. The special keyword to learn here is yield. So here's an example. I created this method up here called block caller. Inside the method, it simply writes out the string in the method yielding to block, put the keyword yield twice, and then I put back in the method. So how this works is here I'm calling the method here, and then I'm passing it the block here. And the keyword yield kind of does as it says. It yields control to the block. So this method gets the block, it yields, and then the block runs, and then the control returns back to the method, and then the method finishes as usual. So I'll just run it real quick. You can see how that looks. So you can see here we get printed out in the method yielding to block, high from the block twice, and then back in the method. So and the yield just basically runs the block. And since we put in yield in here twice, the code from the block was run twice, as we can see here in high from the block. So yield is the needed keyword for this. The next thing is, as we discussed, blocks can accept parameters. So in this version of the method, this is a new version, you can see here I'm passing a parameter to the yield call. Otherwise, it's basically the exact same thing. But this time the block, when I pass the block, you can see here it's expecting a value inside the pipes, and it's just going to print out high from the block with whatever value is passed in. So when we run this, we get similar output to as before, except for now, when the block prints, it prints out first yield, second yield, because those are the parameters that we passed in the method. So the pipes and the parameter name are what's important to note here. Inside of methods, you can also save a block to a variable and call it that way. So you can see in here this block namer method. The key to this working is the ampersand here. A method can only accept one block as a parameter and nothing else. So it always works just to have an ampersand and then whatever you want to name the block. In this case, the block is the only thing we're passing. I'll show you another example where you also have normal parameters and a block. So this is actually the same as the first example, except for instead of putting the keyword yield, you just put the name of your block variable. In this case, it's block.call. And as you can see here, it's exactly as you would expect. In the method, in the block, back in the method. So with an ampersand, you can save a block and name it. And then here's one last example. This does something similar. You can see here it's called block checker. It takes an argument and then a block. And how you call it is you look down here, I'm passing it an argument and then just an empty block in this case. And there's something else I want to show you in here. If you notice in the put statement, I'm running this code called block given, and this simply returns true or false as to whether or not a block was passed to this method. A block isn't like a normal argument. If you want to know if it's there, you have to call this. And then, so I'm just going to run this real quick. You'll see that it prints out block given true, and it prints out that the block is an instance of proc. If we run this without a block, just a normal argument, you'll see that block given is false and the block is actually nil. So again, the thing to learn here is that you can call block given to know whether or not a block was given, and a block must be the last argument in your method, and you have to use the ampersand. Another important feature of blocks is that they are closures. Closures are, I think, best explained with some simple examples. Here's the most simple one. You set some variable in your current scope. So my name equals Rupert. You can see here I'm doing 2 times. I'm going to put hey in that variable my name. And so you see within the scope of the block there is no my name, but because a block is a closure, it has access to all the variables in the scope that it was created in. So if you run this, you see hey Rupert twice. So again, a block um, has access to all the variables in the scope it was created in. Perhaps a little more complex example here to illustrate this better. So I created a class called BlockSaver. It has 2 methods, one called SaveBlock, which takes a block, as we explained earlier, and saves it to an instance variable. And then the method callBlock simply calls the block. And then outside of the class I have this method called setBlock. You pass it a BlockSaver object. It creates a variable and then saves that, calls saver.saveBlock and passes it a block. And this block is referencing the variable that was created within the scope of that variable, of that method. So to use this, we'll create a saver instance. So now we have a saver instance. I'm going to call setBlock and pass it to saver. So it's going to go within that method. And temp is not in scope here, so if I'm going to type temp, it's an undefined local variable, obviously. But if we do saver.callBlock, you'll see that my scope is gone. That's what temp was sent as. So even though temp is out of scope, the block still has access to it. That's what a closure is, really. It just keeps access to all the variables of the time it was created, or of the scope it was created in. As I'm going to show in another example here, if the variable in that scope changes, it's just a reference, so it still will keep track of the changes. So the BlockSaver class here is exactly the same. We see here my setBlockAlt. In here I set the temp variable, save the block, and then change the temp variable. So you'll see here if we use this in the same way. So now we have a new saver object. We're going to call setBlockAlt, pass the saver. Check temp doesn't exist. This was just the return value of the method. So the temp isn't in scope, but if we go saver.callBlock, you'll see that it says I changed the variable. So again, if we look back at this method, originally when the block was created, the value of temp was my scope is gone. But since it actually references the scope it was created in, it will always have a reference to the latest value of whatever that is. And so something to be aware of is that if that scope is still active, any changes you make within a block will be reflected in that scope. So that could be good or bad depending on how you're using it, but it's something to be aware of. To finish off, I want to go over a couple of differences that Ruby 1.9 introduces to blocks. For the most part, it has the same functionality, but there's a few things that have changed. First, I think one of the bigger ones that has changed is, I'll just give an example. So on the top we have Ruby 1.8, on the bottom we have Ruby 1.9. So I created this variable called something, and then I'm going to iterate over this array, and for each item I'm going to call this block, passing it the argument something. So I'll just run it real quick and I'll show you what happens. So it just runs as you expect. It passes it each 1, 2, and then it prints out 1 and 2. But when you look at the current state of something, you'll see that it is 2, which is the last value of the array, so the last thing that the argument had been set to. So you see that, as I mentioned before in the closure section, since a block references the scope it was in, and if this scope is still active, all changes made to this variable inside the block were also made to those variables outside of the block. So something was changed. The variable something was changed inside the block to 1 and 2, and 2 happened to be the last value. So that's how block works. In Ruby 1.9, it works exactly the same way, except all arguments to a block, so in this case, the argument is something, the variable is something, so all variables set as arguments in a block are automatically local to the block. So the scope of this variable something is local to the block. So if we run this, we'll see we get the same printout there, but when we type something, we see that the value of something is still Big Bird. So the difference, we can zoom that out a little so we can see. In Ruby 1.8, the something still refers to the something on the outer scope. In Ruby 1.9, because this is a parameter, it automatically only references the scope of the block. I hope that's clear. So that's kind of one of the bigger changes. And then along those same lines, I'll give another example here. This is a similar type thing. I create another variable, something else. Just real quick, in Ruby 1.8, the syntax isn't allowed. So I'm just showing you that in 1.8 you can't do this. But in 1.9, you'll see here in the parameters of the pipes, I've got a semicolon. And how this works is you specify the variables that are being passed to your block just as usual, but once you specified all your variables, you do a semicolon, and then you have another list of variables, and these are variables that are specified to be in only the scope of the block, just as the other example I gave. So say something else is a variable name you use a lot, and you just want to make sure that you don't ever change the value of your something else in some other scope. You can use this syntax here, semicolon, and then the name of the variable, and that will ensure that something else is a local variable to that block. So in this case, we'll run this, and even though something else wasn't an actual parameter to this block, it was still used as a local variable. As you can see here, we set it to the value something. So that is another change. Those two changes kind of go together so that you can purposely set a variable in a local scope in 1.9, which could be very useful to you. A couple other things that are different. In Ruby 1.9, you can specify default values for variables. You can do that in 1.8. You can also specify splat argument, so that's just an argument with a star, and that just gets all the arguments. And you can also pass a block to a block. You couldn't do that previously either. So really, in Ruby 1.9, the block behaves a lot more like a method as far as the parameters are concerned. And that's it for my screencast. That's it.